All right, guys, super exciting day today. You are about to learn some new symbols and another formula. So, did you know that you can add up a bunch of terms in an arithmetic series? And what that's referred to as the sum. The sum means add everything up. And so here's a new formula. If I'm asking you not for a specific term, but the sum of all the terms, note the S here for sum. That means that you take n over 2. N is the number of terms. So if I wanted like the first 50 terms in a sequence, and if I wanted to add them all up, then this n would be 50. A sub 1 is still the first term. A sub n is the nth term. So in that example I was just talking about, if I wanted the first 50 terms, the first term and the last term are what you do. The first term is a sub 1, and the 50th term in that case would be the last term. So a couple notes. You need to know a sub 1 and a sub n to use this formula, obviously, and you might need to use the formula that you learned in the video yesterday to find one or both of them. We also have this thing called sigma notation. So this looks like a foreign language, and this, you guys, you're going to use all the time next year in calculus. And into our next chapter, which is our last chapter, which is limits and derivatives. Okay, so I'm going to zoom in on this formula here. This formula, or these symbols, this is called a summation symbol. It's a Greek letter sigma, and it means add everything up. And this is the starting term. So if I wanted to add the first term through the 50th term all the way up in a certain sequence, the formula that you learned how to write yesterday goes here. And that tells you that you're starting with the first term and you're ending at whatever number this is. So like this one, we're ending at the 100th term. Okay, so that's how to write it in symbol notation. It's kind of like a new language. You need to know where to put the stuff and what that means. So here's our very first example. I have a formula for the sum of a certain number of terms. It's n over 2, a sub 1 plus a sub n. And I told you guys, if you were formula people, you were going to love this chapter because it's all formulas, plug in the numbers. Okay, so in this case, this is a really easy formula to use. What that means, if I just wanted to write out the first couple terms, I start by plugging in 1 right here, which just gives me 1. And then I go to the next term, 2, plug it in. 3, plug it in. Dot, 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 forever, all the way up until this term tells me when to stop. The 100th term, which happens to be the number 100, is where I stop. And what it wants me to do is add up all of those numbers until we get to 100. And I don't want to sit there and type 100 numbers into my calculator and add them all up. I would rather use a formula. So let's try that. The sum of the first 100 terms in this sequence is, the n is 100 since I'm adding up 100 terms. The first term, I wrote it right here, is 1. The last term, I also wrote it way over here, it's 100. And so that means in your calculator, if you would add up every single number from 1 to 100, you would get the answer of 5,050. Isn't that exciting? Okay, let's look at the second one. This one means start by plugging in 1, then plug in 2, then plug in 3, and then stop at, oh boy, this is an infinity symbol. That is something crazy. You can't add up all the numbers to infinity. And so there's a technical way that we write that. We write the sum does not exist. That's because there's no stopping point. You would literally keep typing numbers in your calculator forever. Another symbolic notation that you'll use in calculus all the time is DNE, does not exist. Okay? So that's an important one. Let's look at question number 3. Find the sum of the first 57 terms of this series. So they didn't give me a symbol notation like this. They just actually wrote out the series. Okay, so I have a formula. Sum of the first 57 terms is n over 2 times a sub 1 plus a sub n. Okay, the sum of the first 57 terms. I know that the n is 57. I also know that a sub 1 is 10 plus, I need to know what the last term is. And I do not want to write out all those terms 57 times. So let's use the formula we learned yesterday in order to figure out what the 57th term is. So I need to find the 57th term because that's what's going to go here in the formula, and then I'll be finished. Okay, so 57th term, what you can notice here is that I'm subtracting 0.5 each time, minus 0.5, so my D is negative 0.5. I'm going to use the A sub n formula that we learned yesterday. I'm going to plug in everything I know. So I want to find the 57th term. That's what's going to go in my formula I wrote over there on the left. The first term of this series is 10. The n is 57. And the D is negative 0.5. Crunch that number in your calculator, and you get A sub 57 is negative 18. That means that all I need to do is plug in that negative 18 right here. And that means that when I type that into my calculator, I get the sum of the first 57 terms. 57 over 2 is a decimal, times negative 8 gives you negative 228. So what that means is if I add up all these numbers all the way out to the 57th term, my answer would be negative 228. And that makes sense because aren't we approaching negative numbers here? And we're actually going to be adding a bunch of negative numbers if I would write out all 57 of them. So that should make sense, like common sense wise, when you're doing these. Keep that in mind. Okay, let's go to number 4. Again, this is in symbol notation, but what I could do is write out the first couple terms of this series if I wanted to. But I'm just going to go right to my formula, n over 2, a sub 1 plus a sub n. Okay, so the n is 10 because this is telling me to start at n equals 1 with the first term and end at the 10th term. So I know that my n is 10. Let's figure out what my a1 is. That means I'm just plugging in 1 to the formula. That gives me negative 1. Okay, let's figure out what my 10th term is. Plugging in 10 to the formula gives me 35. So doing a little bit of work, that's what I wrote in the notes above. You might need to find the first term and the last term for this summation by just using this formula. This is the a sub n formula that we learned how to write yesterday. If you're given the formula, that means plug in whatever number you want for n. If you plug in 1, that's the first term. If you plug in 10, that's the 10th term. This is the first and the last term of the first 10 in this whole sequence. And so when you crunch that number in your calculator, you end up with 5 times 34, which is the sum of the first 10 numbers in this sequence are 170. Okay, this next one is a way to make this a little bit more challenging. Find n. So not find the sum, not find the first term, but find n, which means when I add up all the numbers in this series that starts with 5 and has a difference of negative 2, how many terms do I need to add up to get an answer of negative 55? So what I'm going to do first is I'm going to start with my formula because I always start with my S sub n formula, a1 plus a sub n. Okay. In this case, I know what my a1 is. That's going to go there. And I know my S sub n is going to go here. So I'm going to plug in whatever I know. Negative 55 equals n over 2, 5 plus a sub n. So I have 2 unknowns in this equation. And so what I'm going to do first of all is I'm going to try and come up with a formula for a sub n. And I know from yesterday I have this formula of a sub n equals a1 plus n minus 1 d. And all I'm going to do is I'm going to plug in my a1, which is 5. And I don't know what n is, but I do know what my d is. This is what we did yesterday. We practiced writing formulas for a sub n and just using given information. And so when you combine all your like terms and do all your distributing and stuff, you get negative 2n plus 7. And that's what a sub n is. And that's what I'm going to put in right here into the formula, because then I'm going to get rid of this unknown. I'm going to replace it with this, and I will only have the variable n in my equation. So first of all, I started with the sum formula, and then I got stuck. So, okay, I think I know a different formula for a sub n. This is how to get unstuck. Use the formula for a sub n, plug in everything you know, and this is what I'm going to substitute in right here now. So then I think I'm going to be able to solve it. I'm going to get negative 55 equals n over 2, 5 plus negative 2n plus 7. So I'm just going to combine my like terms. Negative 55 equals n over 2. That would be 12 minus 2n, or negative 2n plus 12, either way. When you distribute your n over 2 into that, now it's just an algebraic equation I need to solve. That gives me 6n minus n squared. How do you solve something with an n squared in it? Move everything over to one side so that you get 0 on the other side, and then factor it. N squared minus 6n minus 55 equals 0. Let's factor real quick. This part should be a breeze because you guys are almost in calculus. That's going to be what? Negative 11 and positive 5. Gives me 2 answers. Does it make sense to have the negative 5th term? No, you can't have negative terms. I want the 11th term. Okay, so in this case, it doesn't make sense to have n equals negative 5. That means n equals 11. Okay, that was a hard one. Maybe star that one. We'll do a couple more practices of those in class tomorrow. But I want to go into this partial sum really quick. The partial sum is exactly the way we did the sum formulas above, except you don't start with n equals 1. You start with something else. So this means that if I would plug in 1 and plug in 2 and then plug in 3 and write all the numbers out, I only want to add up term number 11 through term number 25. And so all you're doing is you're using the sum formula. If you just write the formula every single time before you do the problem, you'll have the formulas memorized before you even get finished with the notes. It's crazy. Anyways, what I'm going to do is start by plugging in my 11. And I'm going to pretend like that's my A1. And the reason I'm pretending like it's my A1 is because that's the first term that I'm going to start adding up, even though it's not the first term of the sequence. I'm just going to pretend like it's my A1, and it's going to go into the formula. When you plug in 11 there, you get 22 plus 3, which is 25. I'm going to do the same thing here with my ending term. My A sub n, which is where I'm ending, is when you plug in 25, you get 53. And 53, and that is what you're going to plug into the sum formula. So S sub n equals n over 2, plug in my 25 and my 53. And so here's the weird thing, is that how many terms are there between the 11th term and the 25th term? So that's the part that you have to kind of think about. You're counting the 11th term and the 25th term. So 25 minus 11 is 14, but you're counting the 11th term also, so it's 15. You can count on your fingers if you want to, but start at 11, that counts as 1, and then go to 12, 13, 14, 15, and count all the way up. You end up with 15 terms between 25 and 11, and that's because you're including both of them. So 15 over 2 is the number of terms in the sequence that you're adding up, starting with the 11th term, ending at the 25th term. Okay, so that means my S sub n is, when you crunch that number in the calculator, you end up with 585. What I dare you to do is pause the video and try number 2 on your own, because that's the last problem that we're going to look at on this video, and then I'm just going to show you the answer and briefly talk through it. So here we go, guys. Last problem. Answer is negative 5005. Reason for that is because you start with your sum formula, but the first term that you're going to look at is the 8th term. So you plug in 8 right there and you get negative 41. The last term you're going to look at is by plugging in 42 to there. And that is how you get negative 245, and that's those two numbers in the formula. The hard, tricky part is if you start by counting on your fingers, starting at 8 as term number 1 and working your way all the way up to 42. The rule is you can subtract them but add 1 because you're including the 42 and the 8. So it ends up being 35 terms if you count all the terms, including 8 and 42 and everything in between. That is how you plug those numbers into the formula. Negative 5005 is the answer. Thanks for watching. We're going to practice a bunch more tomorrow. You guys, the end is so close. Good job. See you soon.